Today, we will be talking about Latin square designs, first introduced by R.A. Fisher. First off, what the heck is a Latin square design? Latin square of order n is an n by n array of cells in which n symbols are placed, one per cell, in such a way that each symbol occurs once in each row and once in each column. These symbols can be anything from letters to numbers to shapes. These are two examples of Latin square designs. As you can see, no matter what box you pick, the corresponding row and column for that box will contain one of each symbol. What makes Latin squares so useful is that it allows to test a certain variable of an experiment while simultaneously controlling two sources of variability that aren't being measured. The applications of Latin squares are slightly limited because not every experiment requires a Latin square. Also, as time passed since Latin squares were first used, more ways to design and execute experiments have been found. What I have found during my research, Latin squares were originally used for agricultural experiments, such as growth of wheat using 4 different fertilizers while having to control for the sun's rays not being equally distributed, and a river on one side of a plot of land being used for the growing of wheat. Latin squares can also be used in an industrial sense when deciding what material to make a part out of depending on things like durability and lack of mistakes made from the part. By using the Latin square design, you can control any parts of the machine that may change the value of our product. These points of variabilities can be how old the machine is and if there are any troubleshooting issues with the machine. To know how to design a Latin square, first you must find the order of the matrix. This can depend on many different independent variables being tested. If there are 4 independent variables being tested, then the Latin square will be a 4 by 4. After finding the order of the matrix, place the n variables in a one-dimensional array that contains every n and no repeats. Then fill each row after in the same order as the first row until you have filled the full matrix. Then, all you will want to do is to number each row of the matrix starting at 0. Depending on the row number, you will shift the element that many times. Once each row has been shifted accordingly, your Latin square is finished and you will see that each row and column is no longer repeated. These are the list of applications and references I used to do my project. Thank you, have a nice day, and I hope this presentation was useful in learning about Latin square designs.